So this video we're looking at removing coefficients. That's maths for physics, and we're removing coefficients. The example here, which is a maths example first up, we've got 3x equals 15. Now you can do a kind of a guess and check and throw in 5 into the place of x and say that x equals 5, because 3 times 5 equals 15. But we need to understand how to actually rearrange it. So how we do the rearrangement, it helps to understand what this actually means to start with. So this means 3 times by x equals 15. Okay, so to get the x by itself, which is the goal of removing a coefficient, to get that x by itself, we're timesing by 3, so we have to divide by 3. So we could write it like this. We could do 3 times x divided by 3 equals 15, or if we're being a bit more mathematical and physicsy about how we go about that, we would write 3x over 3. Now remember, I forgot one thing. We've divided by 3. Well, what we do on one side we have to do to the other, so we also have to divide by 3 on that side. But coming back down to the bottom here, this is how this here is how we should actually do it, with that divided by 3 on the bottom, and then again what we do to one side we do to the other, so we would rewrite 15 over 3 as a fraction. From here 3 over 3 will cancel, so we're left with the x equals 5. Okay, so just stepping down the process again, 3x equals 15, or 3 times whatever variable is in place there equals 15. That means 3 times x equals 15. To remove the 3 and get the x by itself, we have to do the opposite of what we've done. So we've got times, so we're going to divide, and we use the same number, 3 and 3. But what we do to one side, we have to do to the other, otherwise the equals sign is no longer valid. And we write it in this way, with a divide with a fraction, 3x over 3 equals 15 over 3. So those are the bits that we're both doing to both sides to keep the equals the same, and then we finish with x equals 5. You can just put those into your calculator if you're not very good with maths, but those numbers you should be able to work out in your head if you're studying physics at any level at high school, I believe. Okay, so there's one more slightly awkward example for this, and this might be when you have a fraction as a coefficient. So if you had, say, y over 2 equaling 5. Okay, that fraction part there, the over 2 bit, that's our coefficient in this case. So we could easily say that, using the guess and check method, y must be 10, because 10 divided by 2 equals 5. But we've got to do this in an orderly algebraic way to show that we understand what's going on with this. So if we were to rewrite that, we would rewrite it saying y divided by 2 equals 5. So the way forward then is to do the opposite of that divided by bit. So we're going to do y, it's divided by 2, so we times it by 2. Equals 5, and what we do to one side we have to do to the other, so 5 times 2. Okay, and then that gives us, if we're writing that in a more physicsy form again, it's going to be 2y over 2 equals 5 over, not 5 over 2, 5 times 2. Okay, because we started off with that y over 2. And so we've just multiplied it by 2, sticking the 2 next to it, and what we do to one side we must do to the other. Following it through, the 2's cancel, and we're left with y equals 5 times 2, which is 10. Okay. Yeah. If all else fails, you can do it a little bit differently like this. I'll give you a version in red. We have y over 2 equaling 5. You can treat this as half times y equals 5, and then do it in exactly the same way that you did up above. You just divide by half on both sides. But that has some slightly more awkward maths, although you'll cancel that out nicely and just have y equals 5 divided by a half is the same as 5 times 2 over 1. Just remember, when you're dividing fractions, you multiply by the reciprocal. The reciprocal is when you change those numbers, the 1 over the 2 to 2 over 1, and you times instead of dividing. But you get the same answer. Okay, physics example of removing coefficients. If we are rearranging a kinematic equation, Vf equals, no, let's not do that. We'll do D equals Vi t plus half a t squared. You can see our coefficient in this case is a half, and we can also do, so we'll do that for one. And the second one we'll do Vf squared equals Vi squared plus 2ad. Okay, and in both cases we want to get a by itself. So we're trying to get a by itself, a equals something. Okay, so there's actually a lot of rearrangements here, but I'm going to breeze over the parts that are not coefficients, and we're just going to focus on the other parts. So that's the first one. D equals VIT plus half AT squared. The first thing is we've got this VIT bit we need to shift to the other side. So we're going to be left with D minus VIT equals half AT squared. Okay, if you're not sure about that step, watch the video on shifting bits to the other side. Basically, in very short order, because it's a positive, you have to subtract it from both sides, which is how we ended up with that minus VIT. Okay, again, we're trying to get the a by itself. Let's deal with the t squared part. These two bits are actually two coefficients. So we've got half there, and they've got t squared. This is one coefficient, this is another in terms of the context we're trying to get a by itself. So what do we have to do? If it's times by t squared, we're going to have to divide both sides by t squared. So, sorry I got interrupted. We're timesing by t squared, so we have to divide by t squared to move it to the other side. So we're going to divide by t squared. I'm trying to keep my working a little bit shorter for convenience sake, so that'll cancel there. And I'm not even going to try dealing with all of this, we'll just leave it as is. But we're going to have d minus vit, all of that over t squared, equaling half a. So now we only have to get rid of that half from the a. This is a cool thing actually, just trying to make this a little bit easier. You can deal with everything inside of a bracket as one unit. It's just a single number. In fact, I'm going to continue rearranging just with empty brackets to show you what I mean. So we've got empty brackets, whatever's in there, equaling half a. Half a is like dividing by 2, so we have to times by 2 to cancel out the half, but we can't just do it on one side. What we do to one side, we have to do to the other. So we end up with 2 times whatever's in all of that brackets, equaling, so half and the times 2 will cancel, equaling a. So that's the first one done. Okay, next one, which was Vf squared equals Vi squared plus 2ad. I'm going to try and do this in less steps, because by now you should have got it, and I'm trying to work a little bit quicker to keep the video shorter. But we're going to have Vf squared minus Vi squared equals 2ad. We've just, because Vi squared is a positive number, we've just subtracted it from both sides. That'll cancel that, and we have to write the subtraction on the other side, because what we do to one side we have to do to the other. Now we're going to deal with the 2 and the d at the same time. So we could rewrite the right hand side as 2d times a. So we have to try and deal with the 2d, keeping it the same. So the best way to deal with the 2d, because it's times the a, we're just going to divide it by 2d. We can't do that to one side alone. Leaves us with a equals Vf squared minus Vi squared over 2d. You can just take all of that and shift it down to there, whatever's in there. And that's rearranging by shifting coefficients and a little bit of moving other terms to the other side as well.